Hello, my name is Christopher Andrew. I will be presenting to you today on hydrogen fuel cell and battery electric vehicles as replacements for gasoline fueled vehicles. I am doing this presentation for my ENGI 2304 Technical Communications class at the University of Houston. I'll be first speaking on a little bit about how hydrogen fuel cells and lithium ion batteries function. Then I'll be discussing my two criteria, which are lifespan and can you fuel the alternative fuel systems. First of all, though, why is this important? Why do we need alternative fuel systems? As we all know, global warming is becoming more and more of a bigger impact each and every day. And we contribute it each and every day in significant amounts through our commuting and through driving vehicles. We have two options to fix this particular contributor to it. We can reduce the amount of pollution created through these vehicles by not driving as much, making them more efficient, or we can remove the polluting fuel systems in their entirety. We are looking at removing them in their entirety and replacing them with one or two options. The first is hydrogen fuel cells. Hydrogen fuel cells work by reacting oxygen and hydrogen gas to produce water waste and a voltage difference across the two terminals of the fuel cell. The fuel cell itself is comprised of three primary parts outside of its housing: an anode, a cathode, and an electrolyte to separate the two. Oxygen gas is pumped across the cathode, hydrogen is pumped across the anode. Hydrogen ions then pass through the electrolyte to react with the oxygen, and the negative ions pass across wiring connected to the anode and the cathode. Lithium-ion batteries do not produce power on their own. They are instead storing electrical energy in the form of chemical energies. Structurally, they are similar to fuel cells. They have an anode, they have a cathode, they are separated by an electrolyte. They store this energy by creating lithium ions from the cathode, which is as lithium ions deposit on it, and these lithium ions are instead deposited on the anode. During discharge, lithium ions are split from the anode and returned to the cathode. How we get the energy out from this reaction is the negative ions, or the electrons, pass through a wire across the anode and the cathode of the battery. Our first criteria we are looking at today is lifespan, which is measured in miles driven before fuel cell replacement or battery replacement. This was decided because the battery or the fuel cell is the primary difference between an battery electric vehicle and a fuel cell vehicle, as they both ultimately produce electricity to drive motors to move the vehicle. This criteria will be weighted less than the availability of fuel, as if you don't have fuel for your alternative fuel systems, it's largely pointless to even consider other options. Fuel cell lifespan is around 170 to 260,000 miles on average. This is determined at the point where the fuel cell's voltage output degrades by 10%. This is considered the hard limit, as the fuel cell begins degrading faster and faster past this point, and it does not result in a longer lifespan to go beyond it, or not significantly. Battery electric vehicles, on the other hand, last around 100,000 to 150,000 miles per the manufacturer's warranties. This, for our discussion, can be considered an average minimum, because most companies probably do not want to replace the battery systems of their vehicles. This limit is set by the capacity of the battery degrading by about 30%. This is a different degradation than the fuel cells, as it is the capacity of the battery that's degrading, not its output. This is considered a soft limit because you can still drive the car after these limits are hit. It will just have a lower and lower charge, and for us, you have a shorter maximum trip length. Other criteria is the availability of fuel. This is a major factor in determining if we can even use the fuel systems as, well, put it this way, how often do you have to worry about finding a place to get gas? Almost never. When looking at these, you may. For hydrogen fuel cells, this availability is a massive, massive problem. There's only about 43 fuel stations for hydrogen fuel cell cars across the entire United States, with 30 in various planning stages. Most of these are located in the state of California. Availability of battery electric vehicles, however, vastly different. Because they can be more or less charged anywhere, albeit at extremely varying speeds, they have much less availability problems. These speeds can vary from minutes to overnight on a standard wall outlet, assuming your car can use the standard wall outlet outputs. Because of these fuel availability issues, I have to weight them much higher than the lifespan of the system. So I must recommend battery electric vehicles as my replacement of choice, simply because hydrogen fuel cell vehicles can simply not be fueled outside the state of California for the most part. If this were to change, my recommendation would change, but that's as it stands right now. To summarize, we talked how lithium-ion batteries and hydrogen fuel cells function and how they are structured. We discussed the lifespan of these cells and the batteries, as well as how available fueling systems for they are, and my final recommendation of battery electric vehicles. If you have any questions, comments, concerns, you want to just say hi, you can contact me at christopher.s.andrew@gmail.com. But thank you for listening to my presentation, and have a good night.